The purpose of this lab is to use spring and gravitational force and kinetic and potential energy through coding to predict the motion of a mass attached to an oscillating spring, compare the prediction to reality, and generate an energy time graph of the scenario. The system is the mass, the spring, and the earth, and the surroundings are anything outside of these three things that could act upon the system. Example, friction and air resistance. The model used in this experiment was a computational model simulating the oscillation and energy changes in the spring mass Earth system being studied. Fundamental physical principles used are spring force, energy principle, gravitational force, kinetic energy, and potential energy. Preview of results. The change in position of the mass in real life and in turn the spring's oscillation pattern, both in the x and y direction, seems to be around the same as in the simulation. However, it seems to be delayed in real life compared to what the simulation predicts. Main physics ideas used. These are the gravitational force and potential energy, the spring force and potential energy, kinetic energy, energy principle, and the position and velocity update formulas along with Newton's second law. All these physics ideas were used in the coding, and I will explain how they were used and why they were used when we get to the coding. This is a screenshot of the experiment in Tracker. The mass started at rest and then its position was tracked as it oscillated on the spring. The mass of the mass was correctly put in, along with its original position vector and its original velocity vector. Its original velocity vector was 0 because the mass started at rest. The delta t was set as small as it possibly could be without the code crashing. The g constant, spring stiffness, and relaxed length of the spring were all correctly put in, and the formulas to calculate all the different types of energy were put in, and these were the formulas shown on the previous page, and this is how they were applied in the code, and this is why they were applied to calculate the energy and in turn the changes of energy in the system. Here the gravitational force and spring force formulas are applied to calculate the force the spring exerts on the mass and the force the gravity exerts on the mass. Then these are added together to get the net force exerted on the mass, and these are put into the velocity and position update formulas to calculate how the position and velocity of the mass changes over time, and Newton's second law is used to derive these. Then here at the bottom of the code, the different energy formulas are plugged in to find how the energy changes over time. Here's a screenshot of the output of the code, and here is the predicted position of the mass in the x and y direction versus the actual position of the mass in the x and y direction over time. Discussion. The change in position of the mass in real life and in turn the spring's oscillation pattern both in the x and y direction seems to be around the same as in the simulation. However, it seems to be delayed in real life compared to what the simulation predicts. Additionally, the delay seems to become greater as time progresses. Possible sources of error. Delta t could be too large in the code, causing the graphs to become less accurate due to the timestamp where calculations are done not being as small as it could be. Center of mass not perfectly being plotted in Tracker, error in the coding, and also in our code we did not account for drag and force and friction from the spring when these do occur in real life. What does it mean, part 1? In the computational model, the energy principle is satisfied as the sum of the change of kinetic energy, the change of gravitational potential energy, and the change of potential spring energy all cancel out to give a value of 0 for the change in total energy, which is expected as no work is done on the system aside from friction from the spring and drag, but we are not accounting for those. What does it mean, part 2? By using the data found in Tracker, I found the oscillation period to be about 2.375 seconds when observing the mass's motion in the x direction and 2.15 seconds when observing the mass's motion in the y direction. Due to these values being pretty similar, they are probably close to the actual oscillation period. The difference between the two is probably due to drag and or friction from the spring acting on the mass with different magnitudes in different directions and or not tracking the exact center of mass in Tracker. Thank you.